Kranti, you want to start with your introduction and then we'll go around the table?
Sure. Awesome. Hello, everyone. My name is Kranti. I'm the Center Manager for STEAM Citizen. Some of you have seen last week, so it's exciting to see you back again. So today's moderator is Vinay. You can say hi to Vinay, uncle. Yeah. And then your tutors today are Tejasvi, Nishka, Neil. So you're going to learn so much from them, and this session is being recorded. You will get a copy of this after the class so that you can go back and refer, okay? All right, Neil, take it away, please.
Okay, so let's start out by everybody introducing themselves and saying one thing that they like. So who wants to go first? Okay, you, Calvin, you can go first.
Hello, my name is Calvin, and one thing that I like the most is math.
Okay. Now I'll do my introduction. My name is Neil Bhatia, and one thing I like most is gaming. And who wants to go next? Anybody want to go next?
I'll go next. Hey everyone, this is Vinay. I'm going to be a volunteer this year with Math Kangaroo. I work in an IT company. I'm also Neil's dad. I also volunteer with the school. Neil is currently in middle school, so this year I'm volunteering as a PTO coordinator in the middle school. If you guys go to Cottonwood Creek, if any one of you is in Cottonwood Creek, I was the PTO coordinator, website coordinator in Cottonwood Creek for the last 5 years. This year I've handed over. Look forward to meeting all of you guys.
All right, who wants to go next?
Hello, my name is Olivia, and my favorite thing is fencing.
Okay.
The piano.
Anybody else want to go? Sure. Okay, Zion, go.
My name is Cyan, and my favorite food is pizza. Oh.
Who's next? Anybody want to introduce themselves? Or does everybody?
So my name is Nishka. I'm an 11th grader and I love to bake.
All right. Who's next?
That's my classmate.
Okay, Shreyan, you can go.
My name is Shreya, and I like gaming also.
Anyone else want to introduce themselves before we get started?
My name is Ethan, and I like baseball.
Lokia, you want to go?
Yeah. My name is Lokia, and I like drawing.
I think that's everybody. Has anybody not had a chance?
Hi, my name is Tejasvi. I'm one of the teachers. Something I like doing is playing piano and singing.
So let me start with sharing the screen. Kranti, I don't have rights to share the screen. If you can make me the participant, the host to share the screen, or you can share the screen, Kranti.
Sure, let me actually give you the access. Oh, yes, I'm going to make you the host and let's see what happens. Okay, you should be the host now.
Yeah.
But I think Vinay, you have to start recording. So if you can record to the cloud, please, okay?
Yeah.
Thank you.
I've started sharing. Let me see how I can record.
There should be a round button after the AI companion summary and AI companion in the bottom of the screen.
No, the options I'm getting is pause recording and stop recording. So I believe the recording is already on. I'm not getting an option to start the recording.
Oh, because for me it shows
The only option to get in the pause recording and stop recording.
Okay, hold on. Let's see.
It's still recording. It didn't stop recording.
Oh, it's still recording? Okay.
Yeah.
All right. So let's hope that, it's keep going on. Go ahead, Vinay.
Yeah.
Continue,
So I just wanted to confirm everyone is able to see my screen. All right. Yeah. So let me go to the next page. I hope everyone is aware of the Zoom basics, how to mute, unmute, and chat. If you have any questions, you can paste in the chat window and also raise your hand, and then we'll come back to you. When we discuss problems, we normally go around the table. Everyone gets an opportunity to solve the problem one at a time. And again, some basics of Zoom. I know all of you have been doing various online classes for the past couple of years. Some of them don't get into the Zoom details and how to use Zoom. In fact, I'm learning from my son Neil how to use Zoom. So with this, Neil, why don't you tell everyone about what is Math Kangaroo and what kind of problems they ask in Math Kangaroo? Why don't you walk us through the format of Math Kangaroo, Neil?
Okay, so Math Kangaroo is a math competition from students from grades 1 to 12. There's 24 questions for y'all and 30 questions for higher grades. It's a 75-minute test with 3 kinds of problems: easy problems, medium problems, and hard problems. Each is worth a different amount of points, which is on the board. So you might be wondering, what is problem solving? Problems are different from exercises. Note that. In an exercise, you're practicing a technique or a skill. You know how to approach it, and you just need to go through the steps to solve it. In a problem, you don't know how to solve it or approach it, and it demands thought and resourcefulness. Problems often involve trying different strategies, making mistakes, starting over, and repeating that until a solution is found. So here's an example of an exercise. Pia is making shapes using the connective stick shown in the picture. Which one of the following shapes uses more sticks than Pia has? So anybody want to try to solve this?
Cyan raised his hand.
Okay, so you can.
Okay, so here's how you should solve it. So first we need to count how many sticks are shown in this picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we need to look for the one that has more than 10.
Okay. One thing I have to say is, if you don't already, there's a drawing feature, but you can use to write down stuff, circle stuff, use it to your desire.
Oh,
They make it
okay,
easier to
so
solve the problem.
this is, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this one has exactly 10, but 10 is equal to 10, not greater. So now we need to find out the value of feet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So B is 10 again. So now 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, this one was 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So Pia has 10 sticks, but so 12 is greater than 10. So D is the answer.
Okay, D is the correct answer. And if anybody used an alternate method to solve it or got a different answer, please let us know and show us. Okay, next
So,
one.
come forward. Before I move forward, right? There are small ways to solve it and make it faster. In the exam, you have limited time, and you have to solve as much as you can. Try to complete all the problems. If I was solving this, at least for the symmetrical ones, for example, E is symmetrical. I'll just count one side: 1, 2, 3, 4, 5. And then I'll multiply by 2, 5 into 2, 10. So I will avoid counting twice, at least for the symmetrical ones. So if you look at B, I'll just count this, 1, 2, 3, 4, 5, and then I'll multiply by 2. And that is how you can save time. So these small tips, if you practice now, it will help you in the exam. All right, guys, everyone got it? So I'll move to the next problem, and Tejasvi, why don't you walk us through the next problem?
Yeah, of course. Okay. So this problem says Lewis had 7 apples and 2 bananas. He gave 2 apples to Yuri, who in return gave some bananas to Lewis. Now Lewis has as many apples as bananas. How many bananas did Yuri give to Lewis? So I'm going to give a little tip here. If this seems a little confusing to you, break it down in small parts. Like even a sentence, break it down in half and see if you can get any information from it.
Shreyan, could you erase the stuff you drew on the board? Please.
Let's take 20 seconds. Every one of you try to solve it, like have a piece of paper or on your iPad. Try to solve this. And once you finish solving, raise your hand. We will call you to answer. So take.
Shreyan has raised the hand.
Okay, and let's give your friends another 10 seconds, Shreyan, so that they can solve, okay?
Okay, Shreyan, do you want to give this a try?
Yeah. So, like, he has 7 apples and 2 bananas. And he gives 2 apples to Yuri, which means 7 minus 2 equals 5. So he has 5 apples. And then if Yuri gave bananas in return, and now he has the same apples as bananas, it would mean that it would equal 5 equals to 5. So like the answer is like, and then since he already had 2 bananas, and it says how many bananas did Yuri give to Lewis, you gotta subtract 5 by 2, should equal 3, and then 3 bananas would be your answer.
Yeah, that's correct. Good job. Can I ask how you began to try and solve this? What made you, what skills did you use here? Like, did you split it up?
Wait, first, I just read the question, and then, like, I tried to understand the question, bro. Like, as I started to like understand it, I realized that he has 7 apples, and he lost 2 apples, and he still has 2 bananas, which made me subtract and then get the answer.
Okay. Did anyone have any other way to solve this? Everyone got the same answer?
I got the same answer.
I got the same answer.
Good
Me
job to you
too.
all.
I got the same answer.
Very good.
Yeah.
All right.
So one thing we wanted to highlight, the previous one was like a problem, you can solve it in a particular way, and this is what we call as exercise. Normally, exercise will involve multiple steps. As you saw in this problem, there were multiple steps. First, you converted from A to B, from B to C, and then you got the final answer. So as you progress, some of the problems which gives you, or exercises which give you more points, more score, they are normally exercise to solve. You have to follow a particular set of steps. Now with this, we are going to move to the next slide, and I'll invite Nishika. Why don't you walk us through what are the different types of problems that are asked in Math Kangaroo?
So first, there are number problems. And on the next slide, there's actually a type of number problem. And then there's geometry and measurement. There's visual thinking, spatial thinking, clocks problems, and logic problems.
Yeah. So should we go to an example of the number problem, Nishika, and then you can walk us through a number problem.
So this is a good example of a number problem. Sarah has 16 blue marbles. She can trade marbles in 2 ways: 3 blue marbles for 1 red marble and 2 red marbles for 5 green marbles. What is the maximum number of green marbles she can get? So it might be helpful to split this problem up a little bit into different steps to make it easier.
So who wants to try solving this particular example? Oh, this is the one we always.
Kavin raised first. Sorry, Vinay, you were saying something.
I got confused if we solved this on the previous one. Yeah, so Kevin, go ahead.
Sarah has 16 blue marbles. It says in the problem she can trade it 2 ways: 3 blue marbles for 1 red marble and 2 red marbles for 5 green marbles. What is the maximum number of green marbles she can get? So first, you have 16, and you need 3 blue marbles for 1 red, and 16 isn't divisible by 3, but 15 is divisible by 3, which gives us 5. So we still have 1 blue marble remaining. We do nothing with that. And since we have 5 blue marble, wait, no, not 5. Yeah, 5 blue marbles.
Kavin, you
Wait.
use the annotation. You can use a pencil or pen from the annotation to write on the screen. So
What was it? The whiteboard thingy?
No, not the whiteboard. The annotation. Just
I don't
not the
see that
whiteboard.
there.
If you tap your
so-
screen, you might see a little pencil icon somewhere, which you can use.
No, I don't see any. I don't see any. Oh,
Yeah,
yeah,
he's seen.
there. Okay,
Go ahead,
so
use that.
yeah,
Thank you, Nishka.
She has 16. And it has to be divided by 3. But that is not impossible. Sorry, that is impossible, well, unless we go into decimals. But technically that is impossible because 16 is not a multiple of 3. The only multiple closest to 16 of 3 is 15, which divided by 3 is 5. So we have 5 blue marbles now. Sorry, not, and then we have to trade it for 1 red marble. So 3 blue marbles for 1 red marble. So we still have 2 left over. So we have 1 red marble. Sure, 1 red marble, but we have 2 red marbles for 5 green marbles. So my answer, I think, is we can only get 0 because we don't have enough. Wait, no, never mind. Wait, so
Kavin, so it's okay. You can erase what you wrote and try again. Right, give it one more try. You're on the right track.
So 15 divided by 3 equals 5. So since we have 5 now,
So given if you can just say 5 of what? So if you trade in 15 blue marbles, you will get 5 of what?
5. We have 5 red marbles. 5 red marbles.
And what can you do with 5 red marbles?
We can trade 2 red marbles for 5 green marbles, but since 5 is not a multiple of 2, and the closest multiple of 2 to 5 is 4, we can get 2 5 green marbles, which then 2 times 5 equals 10. So my answer is 10 green marbles. That's the maximum she can get.
That is correct. And I failed to understand. She can't get more than 5 marbles, 5 red marbles, because you can't really cut a marble into turns. So strategy was correct. Did anybody use a different strategy or get a different answer?
Good job, Kavin.
Wait, how do I just get out of the?
There's a red X which you can click on to get rid of the.
I already did.
So I think Shriyan is raising his hand. Did you have a different way, Shriyan?
I did it in almost the same way, but I did it just kind of different. I kind of did the division different. So it's 16 marbles, and she can trade it in 2 ways: 3 blue marbles for 1 red marble, 2 red marbles for 5 green marbles. So if there's 3 blue marbles for 1 red marble, then we have to break up 16 marbles into groups of 3. So then I divided it, and I got 5. But I got like a remainder of 1. But I don't use the remainder since you can't really cut a marble and use it for the trade. So we just get rid of this remainder. With that 5 red marbles, it's 2 red marbles for 5 green marbles. 5 divided by 2, 5 divided by 2 equals 5 divided by 2 equals 2, with the remainder of 1. And just like the first time, we don't use the remainder. So we can trade 2 times for 5 green marbles. And then the 5 green marbles we traded it 2 times, and 5 plus 5 equals 10.
Good job. That's the right answer. Oh, just as a challenge, can I ask you, what are all of the different numbers of colored marbles that Sarah has? Like how many red marbles, how many blue marbles, and how many green marbles?
As a reminder, Sarah has 1 blue marble, 1 red marble, and 10 green marbles.
Yeah, good job.
Excellent. So this was a type of number problem as well as the previous one. Now Math Kangaroo has different type of problems. The next problem we'll look at is what is called as a geometry problem. So let me go to the next slide. Let's clear the annotations. If you can clear the previous annotations, it will make it easier to read. Neil, why don't you walk us through the problem and then we'll ask one of the students to solve it.
Okay, so the problem is the large rectangle is made up of a number of squares of various sizes. The 3 small squares each have an area of 1. What is the area of the large rectangle? Like this overall rectangle, the big one. So the first step you would take is see how many of these small green ones, I mean, not green ones, the small ones, can you use to make this one?
Yeah.
So if you measure,
So
they're all
before getting
squares.
to the solution, let's give 20 seconds for other students. Let them try to solve it on their own. And if anyone is able to solve it, they can come and present name. Is that okay?
Okay.
Yeah. So I'll give everyone 20 seconds. We'll pause here.
Okay, does anybody want to share their answer or is everybody still working?
I see everyone is still writing with the pen and paper, so they're still solving it. This is a multiple step one. To arrive at the final answer, you need 7 to 8 steps. So I see Ethan has raised the hand. We'll allow Ethan to present his solution. Ethan, go ahead and you can, I'll ask everyone to look at the solution and then learn from it. Go ahead, Ethan.
As you can see, the smallest squares each have an area of 1. And once they're all put in a line, the line on the top of them is 3, which means the square above them has an area. The sides of it are 3 by 3 by, sorry, wait.
Yeah. Do you want to use annotation and write on the screen? If you use annotation and write on the screen, it will be easier for you to see.
How do you draw on the screen?
Is there
So,
a pencil mark?
there's a pen button in the lower left corner that if you press on, you can use to annotate and show us your thinking.
So each of the small squares is equals 1.
Yeah.
And so this line over here is an area. Oh, no.
It's okay.
It's okay.
To make this problem more understandable, I think we should label these different squares with like
The
this small
length,
would be A, this could be B, C, and D. So if you're gonna explain, could you use these terms to refer to them? To make it easier for everybody to understand.
so each of the small squares equals 1. And there are 3 of them. So this top line has a length of 3, which means one of the sides on square A equals 3. So 3 times 3 is 9.
9. Can you write it down somewhere? 3 by 3 equal to 9. So later on we'll need to add. That's correct. Yeah. So just write 9 somewhere. 3 by 3 equal to 9, and then we'll go to B.
And then for B, the side of square A, one side of square A is equal to 3. And then as you can see, one of the small squares also is next to one of the sides of square B. So 1 plus 3 is 4. So the area of B has to be 4 times 4. So 4 times 4 is 16.
Yeah, that's correct. Can you write it down on the screen? We'll remember that.
So then, now we should get the area of C. So one side on the square of C has to be 9 plus 16. Because as you can see, those are the 2 squares right there.
This one.
It's not.
9 and 16 is the area. You don't have to add the area, you have to add the side.
And then 3 plus 4. So 3 plus 4 is 7. So 7 times 7 is 49.
Yeah.
So the area of C is 49.
So
So
for this problem, I would recommend that you don't find the area of each individual squares. You find the side lengths, then multiply the side lengths to the large rectangle to make your life much easier, and instead of having to do addition of all of these squares.
Yeah, that's an alternate way, Neil. We can talk about the alternate way. That's a good idea. Let Ethan solve, and then Neil, you can present the alternate way.
So then, for these 2 squares, which I made a dot on, those 2, the length of one of their sides is 7 and 4. 7 plus 4 is 11. So then we should do 11 times 11 to figure out the area of D, which is 121. Then we just add all of them, and we get our answer. So I'll just do the 3 plus 9 equals 12, and then 12 plus 16 equals 28, and then so on, and then 28 plus 49 is 77, and 77 plus 121 is 198.
That is the correct answer. Now, did anyone else solve it differently than what Ethan presented? Ethan, good job. That's the right answer. And as you saw,
I think
5 or 6.
Olivia.
Olivia, you have raised your hand. You can unmute yourself, Olivia.
So, how I did it
You dropped a 1.
Yeah,
was
Olivia.
I saw that all the tiny squares equal to 1. So then each side of square A must equal 3. So then we look at square B, and each side of square B equals to 4.
That's correct.
And then we look at square C, each side equals to 7. And then we look at square D, and each side equals to 11. And then since we know, like, we add up one side, so we'll add up this side, and that side equals to 11. And then we go to another side, and this side added up equals to 18. So then since the length times the width equals to the area, then 11 times 18 equals to 198.
Excellent. That's a good way to solve, Olivia. And as you can see, both Ethan and Olivia got the right answer. But Olivia, she was able to avoid a few steps, and she was able to solve faster because she just calculated a side. Neil, is this how you wanted to present, as a shortcut, as a faster way to solve?
Yeah. Instead of adding up all of these sides, you could just add up, adding up all the areas of the squares, you could just measure the sides. I think this is a way faster method, and you should try using this method because it will save you time. And time is key when you're doing Math Kangaroo problems, because you only have a limited amount of time on the test.
Yeah. A few others have raised their hands. If you solved it differently, you can come forward and speak. But if you solved it in the same way, just say we are good, and then we'll go to the next problem. We have a lot to cover. Yeah. All right, then if everyone is okay, I'll move to the next slide. If you can clear the annotations. And what we have covered so far is number problems. We covered geometry problems. The third type of problems, which are more interesting and my favorite, are visual problems. Tejasvi, why don't you walk us through the visual problem, and then we'll bring up the next slide, which has the actual problem.
Yeah, so visual thinking helps us visualize problems, and visual thinking problems help train and connect different parts of our brain. Math Kangaroo is famous for having fun visual thinking problems. Here are some examples. So this one says, Jorge glues the 6 stickers to the faces of the cube. The picture shows the cube in 2 positions. Which sticker is on the face opposite of the duck?
Now, I'll give a chance to someone who has not solved it yet.
No. Okay, Emily, you can go ahead and solve it for this. Show us your steps.
So, like, you can't see like the thing opposite the duck really, because like all of them are next to the duck. So, I'm just going to like cross out all the things that I already see. So, this elephant, I see it like next to the duck here. So, it can't be opposite the duck. So, cross 8 out. And the mouse thing, B, like it's next to the duck here, like the duck is right over here, and like again that can't be opposite, so cross out B. And then C, it's just like a ladybug maybe, and then it's also next to the duck, so it can't be opposite either, so cross out C. And D, is this like dog thing, and then the dog is like right next to the duck, so
D can't be our answer, so it must be E, because you can't see like its opposite, and it's like the only reasonable answer.
That is correct. Did anybody have any alternate solutions or alternate answers?
Did anybody solve this a different way?
All right, looks like nobody had an alternate method. So let's move on to the next problem.
Yeah. So Nishika, why don't you walk us through the next problem? Now we saw different types of problems. Today we are going to cover one more type of problem, which is called a spatial thinking. I'll invite Nishika to walk us through what is spatial thinking, and then we'll bring up a problem.
So spatial thinking is related to visual thinking, but emphasizes spatial relations, object location in space, and the change between 3D and 2D plane of an object called surface development. Here are some examples. So on the next slide, we have an example. So it says Los looks at the pyramid from above. What does Lois see? So I'll give you a little bit of time to solve this problem.
We'll give everyone 10 seconds to look at the problem and see if you can solve it on your own. Feel free to use a pen and paper.
All right, Olivia, would you like to solve this problem? You've been like pretty silent for this entire thing, so would you like to solve this?
Okay, so first look at this one. So we see that there's two blank ones, and two blank ones, and one white one and one black one. So as you can see, there's this and this. But since he is looking from above, it cannot be this because he is not looking from a side. So it should be this one.
Yeah, that's the right answer. Did anyone else do it differently?
Shian has raised his hand. Shian, why don't you unmute yourself and then walk us through?
Like, I didn't like, if you see that there's one white line, one black line, and two gray lines. So there's two options. We can't have that. We can't have B because B, it's opposite from each other. And in this picture, it's right next to each other. So B is not an option. A can't be A because there's only one black line, which means that it can't be A because A has two black lines.
Mhm.
It can't be E because E also has two black lines. That leaves us to C and D. If you look at this from like the back, then you would see these gray ones. Then from the back, you'd probably see this as the white one and this as the black one. And then if we looked at the back of this, it's the same pattern. So that leaves us to C as the correct answer.
Job.
Excellent.
So this is one of those problems where instead of looking for the right answer, it might be easier to look for what's wrong and cross out those instead.
All right. So let's, if you can clear the annotations, I'll go to the next type of problems. Now, Math Kangaroo is interesting because there are different type of problems they ask. It really challenges you sometimes. You can have a lot of fun. The next type of problems are what we call as clock and calendar problems. I hope everyone needs how to read a clock and you know what's a small hand and the big hand. If not, we'll guide you today. Neil, I'll invite you to come and present this type of problem statement, and then we'll bring up a problem in the next slide.
Okay, so let's make sure. Does everybody here know how to read a clock?
Yes.
Looks like everybody here knows how to read a clock. So if you know how to read a clock, these problems should be relatively easy. So certain problems work with our time perception skills and can be useful for our daily life situations. Matt Kangaroo has some interesting clock and calendar problems. They sometimes have spatial thinking elements, which make them extra fun to do. So here's our clock problem example. I noticed 4 clocks in the wall, which you can see in the picture. Only one of them shows the correct time. One of them is 20 minutes ahead, another is 20 minutes late, and yet another is broken. What time is it now?
Okay, 30 seconds, everyone. Try to solve it on your own, 30 seconds, and then we'll invite a volunteer to come and present the solution.
All right, is everybody ready for an explanation? So who would like to demonstrate for this? Does anybody want to demonstrate, or is everybody still solving?
Can you guys give us a thumbs up once you're done with the problem? It might help a little bit.
Nishika, I missed what you said. Can you please repeat?
Oh, I said, if any of you guys are done with the problem, just give us a thumbs up on the screen so that we can see who is done and who still needs time.
I see. Ethan has raised the thumbs up. So we haven't heard Sayan and Lokia speak today. Will you like to speak and walk us through, or you want to give this one a pass? Lokia, will you like to present this one, or do you want to wait for someone else to present?
Wait.
Okay, it's okay. Yeah, we'll have someone else present and we can learn from others. Neil, whom should we give the turn? I see who has raised hands. Kevin has raised the hands, right? Kevin, do you want to come and present your solution?
Never mind. I forgot what I was going to say.
Okay.
Okay, then, Ethan, do you want to present?
Shriyan has raised a hand. Shriyan, go ahead and present. Unmute yourself, Shriyan.
Okay, I think that like it says 4 clocks on the wall, and only one of them shows the correct time. And I noticed that all of the clocks are in this period of time 5, other than this one, which means this one's the broken one. I see that this one shows 5:20. This one shows 5:40, and then this one shows 5. That one shows 5:05. So like this is like I think this one like let's say this one is A, this is B, this is C, this is D. I would say like the clock on the left bottom corner, because like it's showing 5:20. The other one is the closest to 5 o'clock, and then it's 5:40, which is 20 minutes ahead, and then 5 o'clock is 20 minutes late.
But can I ask you something? Is that 5:20 or is that 5:25? The clocks at the bottom left.
The clock at the bottom left,
Yeah.
it's 5:25.
Yeah.
So, Shreyan, can you erase all of it and for each of your clocks write the time underneath it?
Okay. Can't find the pencil button again for like the erase button.
There's a trash can button which you can click to delete it all at once.
No, like I mean I can't find the pencil button that I like use to open the trash can button and the pencil and all that.
I'll clear for everyone. Yeah. Do you want to write the timing for each of the clock? Let's first call them A, B, C, D, and then you can write the time for A, B, C, D.
Okay. A, B, C, D. So A, it's broke.
No, what's the time? Before you decide what is
And
broken.
then A is also it's
What's the time?
4, it's 4:45. D is 5. D is 5:40. B is 5:05, and then C is 5:25.
All right. And why do you think now they have asked, given a particular pattern? Do you see any patterns there? So read the problem again. Read the problem statement again.
I noticed 4 clocks on the wall. Only one of them shows the correct time. One of them is 20 minutes ahead, 20 minutes late, and another is broken. What time is it now? I think it's C. I think the right time is C.
Oh,
Okay.
Shreya, the problem statement is one of them is 20 minutes ahead and then one of them is 20 minutes late. If C is the right time, do you see a clock with the time 5:45? No. So C cannot be the right answer because there's no clock with 5:45. Let's pick A. If you take 4:45, is there a clock which is 20 minutes earlier? Do you see a clock with 4:25? No. So A is not the right answer. Let's pick B. Why don't we solve for B? What is B is 5:5. What is 20 minutes before 5:5?
20 minutes from
Before 5.
is 20 minutes from 5 is 20 minutes from 5:05 is 5:25, and 20 minutes minus 5:05 is 4:45.
Yeah. So does B meet all the conditions?
Yeah.
Yeah. And so I believe B is the right answer. You can quickly eliminate C. Does C meet all the conditions?
No.
No. Does D meet all the conditions?
No.
No. So the right answer, what do you think?
It's B.
B. Does everyone agree?
I agree.
That's
I
good.
agree.
Guys, after dinner, before dinner today, ask this question to your parents. Okay.
Okay. So we are running out of time. Is everyone okay? If we extend and do a last problem and then we'll end for the day. Let's cover one more type of problem. The reason I want to do a last problem before we end the day is we wanted to show you some variety of problems that are asked in Math Kangaroo. Now this problem may take more time. Tejasvi, do you want to walk us through the problem?
Yeah, sure. So this problem says the buildings on Color Street are numbered from 1 to 5. Each building is colored with one of the following colors: blue, red, yellow, pink, and green. We know that the red building is next to the blue building. The blue building is the building between the red building and the green building. What color is the building with number 3? So what I like to do in this situation is read it first and decide if, read it in small chunks. Because for me, it's confusing if it says the blue building is between the red building and the green building. So I would say read it first, carefully, and then try and jot down. Shreyan, do you want to give this a try?
Yeah. Like, if it says that the red building is only next to the blue building, if it's only next to the blue building, then it has to be one of the side buildings, which makes it 501. Let's go with 1. So let's say 1 is red. Then it's next to the blue building. So 2 has to be blue. And if blue is between red and green, then it's between red, but then 3 has to be green. And the same situation goes on for 5. If you pick 5 for red, then only has to be side blue, which makes 4 automatically blue. And then the third one has to be green because the blue building is in between red and green. So what color is number 3? The number 3 is green.
Yeah, that's correct.
Wait, I think I just realized the flaw with this problem. The answer might not always be green because it says that the blue building is between the red building and the green building. This means that the green building could be anywhere. It could be here. The green building could be here.
No, but there's no flaw in this thing because it says the red building is only next to the blue building. And if it was in one spot other than the edge, then it wouldn't be only next to the blue building, which would make green correct.
Well, if you see here, the red building, if you put it as number 5, number 4 would become the blue building. But the green building could be either 1, 2, or 3. Because even if it's 1 or 2, the blue building is still between the green and the red.
So Neil, in this problem, right? The first condition that's given, the red building is next only to the blue building, right? It's kind of setting an assumption that the positions are given one at a time, meaning if something is between something and something, it's right next to it, right? The language is not saying it can be anywhere between, right? So while your question is very valid, like what guarantees that the green building is actually not, fourth or fifth positions, right? Because the red could still be in the middle, the blue could still be in the middle, right? But the first statement is giving an assumption that you're going one after the other. There are consecutive homes that you are considering for placement. Right, Neil?
The blue, we're assuming that like the blue, and they mean that like it's right next to it, like right between, like between and like, so red and green, and like there's a blue in the middle, and like we're assuming that it's just like right next, green is next to 4, and then red is next to blue.
So to summarize, I think the answer is green, and what Kranti explained, that the way you read the problem statement when it says that the blue building is between the 2 buildings, they're talking about adjacent buildings. It cannot be after 1 or 2 other buildings, then there will be other buildings in between. It's grammar. Sometimes you have to try to think from the one who has set the problem, how they have tried to set the problem. So you have to interpret the grammar correctly there. Yeah. With this, I think we are just over the 1 hour that we had planned. Let me clear the annotations first. Who would like to recap? Tejasvi, do you want to recap today's session, what we have done today's session, and then what will be the next steps for the class?
Sure. So to recap, you've seen examples of the 6 main type of kangaroo problems that we have during the test. So we have the number problems, the geometry and measurement problems, the visual thinking, the spatial thinking, clocks, and logic problems. So which type of math kangaroo problems excited you the most and why? Does anyone have any preference?
Okay, let's go one by one. Shriyan, which one excited you the most?
Wait, the one that excited me the most was the like rectangle one, where we had to guess the big rectangle area.
Yeah, that's the type of geometry problem, geometry and measurement. Excellent. Kevin, which one excited you the most?
For me, the spatial thinking one excited me the most because it just helps you think more. It's kind of challenging to me. That's what I like, challenges.
Wow, I appreciate your attitude. You like challenges, the most challenging one you like the most. Excellent. Olivia.
I think I like the logic problems because you have to like kind of think outside the box.
Excellent. Ethan, which one excited you the most?
I need some more time to think.
Okay, we are short of time. I'll move ahead. Lokia.
The one that like had the clocks.
Any reason do you love clocks or do you love time?
Yeah.
Excellent. Did I miss anyone? Shreyan, Sayan.
I also like the clock ones because it was a challenge.
Excellent. So moving on to the next slide, Tejasvi, do we have time for this? Do you want to quickly summarize and then we'll call it a day and walk us, Tejasvi, you walk us through the slide and then tell us the next steps.
Yeah, sure. So this is called Genius Hour time, and pretty much it's a great way to become a problem solver and create your own problems to even solve. This course has a Genius Hour project. You will create your own Math Kangaroo type of problem and present it during our last class. It may sound hard, but remember that good problems get inspiration from hobbies and interest in real life. Let's take a look at a problem created by a 4th grader who is crazy about science. So this says superconductors make magnets levitate. See image to the top right, which is right there. For Christmas, Neil wanted to serve candies on a levitating magnet. How cool would that be, guys? The height at which a magnet levitates is based on this formula. 9 minus the weight of the candy in grams divided by 2. Neil chooses from a box of traditional holiday candies. The red ones weigh 2 grams each, the yellow ones weigh 1 gram each, and the green ones 3 grams each. Neil wants to have at least 1 red, 1 yellow, and 1 green on the magnet. What is the greatest number of candies Neil can put on the magnet before it collapses on the superconductor?
This is a different name. This is not the Neil Bhatia of the class. This is a different Neil. Just the name matches. Yes. So instead of solving it today, this is just a type of problem created by one of the students. What I'll encourage is all of you take your time, think about the problem, and then you can share it with your parents, your siblings, or one of your friends and see if your friends can solve the problem. And this was just to excite you, just to give you the kind of problems that you can create on your own.
Wonderful. Excellent job, guys. So can we all thank Mr. Vinay, Nishka, Tejasvi, and Neil for an excellent lesson today? Yeah, big round of hands.
Thanks.
Yeah. You guys will receive homework. So solve the homework and come back with the questions that you found hard or could not solve. And your tutors from today, they'll help you solve them in the next class, okay? Everybody like the session?
Yeah.
Coming back
Yeah.
for the next one?
Yes. Yes.
Telling your friends to do Math Kangaroo problems?
Yes.
Yes. Awesome. Yay.
Before we end, thanking the session for this class and various other classes for bringing the whole team together. And this weekend is Diwali. For those who are celebrating, I'd like to end with Happy Diwali. Enjoy the festival.
Happy Diwali, y'all.
Happy Diwali.
Thank you. Bye.
Happy Diwali. Bye, everyone.
Bye.
Bye. Bye. Leave.